All right. So here's what I want you guys to do to start off with, right? We're talking about transforming functions, and all we're going to do is take what we did on Friday with absolute value, and we're going to make it general, right? So we're going to say instead of an absolute value function, shifting up, down, left, right, flipping, changing slope, we're going to take it to any function that we want, okay? And so I just made up a function this morning. I called it f of x, and this is what it is. So on your first graph, I want you guys to copy down f of x, okay? And there's really only 3 points you need. So copy down those 3 points and then just connect them with a line. So we got 1, -1. We got 2, 2. And we got 5, 3. Okay. So graph this on the top graph and label it as well. Label it f of x. All right, now just as a reminder, in terms of terminology, so just ignore the graph right now. Let's say I gave you a function like this, f of x equals x plus 2. We called x an input, right? X is an input, a domain, an independent variable. What do we call f of x? What are vocab words for f of x? Yeah.
Function of x.
Okay, that's what it is, right? A function of x. But if x is the input, or yeah, your input, your domain, Mitchell, what's f of x?
Output.
F of x is your output, and that's what we're going to kind of focus on, those two words today. We're going to focus on inputs and outputs, right? And so remember, f of x is an output, right? It tells you what you get out. Once you plug in a number to your function, f of x is what you get out. So f of x is our output, all right? So now in this next graph, we are going to graph f of x plus 3. So don't do anything yet. Let's talk about this. So think about your inputs to this function. Right now, this can be kind of tough at first because this is a really general idea when everything we've done this year has been really specific. So let's think about this function, x. This is your input, right? Now, are we changing any of the inputs? Meaning, does anything happen to x here on the inside of these parentheses? Is anything happening to x? No. But then think about your output. So f of x, this is your output. Once you get your output, what do? If you given what we wrote here, you have your output, what do? Mitchell? You add 3. So output is another word for range, which is another word for y. So instead of, we're not going to change any of our x values, all we're going to do is change our y values. So when you add 3 on the outside, you're going to shift your graph up. So then our new graph should look like this. We have 1, -1. Well, if we're adding 3 to it, 1, -1 should become 1, 2. We added 3 to our outputs, right? 2, 2 should become 2, 5. And although this one's a little bit off the graph, that's right. 5, 3 should become 5, 6. All we did was we shifted everything. This is a shift up 3. This should look very similar to our absolute value because when we added something on the outside of the absolute value, what did that do to our vertex? It moved it up, right? If you added it and if you subtracted it, it moved your vertex down. This is the same idea, but we just took some general function, right? And then we're adding 3. So this is going to shift our outputs, or shift the whole thing up 3. That's it. All right. All right. So then let's keep going. And remember, everything we're doing today, compare it to absolute values, right? Compare it to absolute values from what we've already done. All right, our next one. We're going to take the graph, f of x minus 3. Now, you guys have that graph right at the top in front of you, right? We don't have it on the board, but that's all right. You can see it in front of you. So now, let's go back to what we were saying. F of x is your output, and the x is your input. So what? These are your inputs, right? So now, if you have a minus 3 on the inside, you're not changing any of the outputs yet, right? Or just at all. All you're doing is changing your inputs. So with an absolute value graph, if we have the absolute value of x minus 3, what did that minus 3 on the inside do to our absolute value? Think of in terms of the vertex. I feel like we're hearing from the same people. If you had a minus 3 on the inside, Spencer, what did it do to your vertex?
It shifts your vertex horizontally.
And let's be specific now, right, or sorry, I just said it.
Or right 3.
Yeah, minus would be right 3. So your inputs are going to change. This is going to be a shift right 3, which is why I changed the graph from that 5 by 5 to this 10 by 10 graph, and you guys don't really have that. So it's going to go off to the side for you guys, but that's all right. So think about your values. We had 1, negative 1. It's a shift right 3, so 1, negative 1 is going to become 4, negative 1. Our output didn't change, correct? The output of negative 1 stays negative 1. We're changing, it's a right shift of 3. So then 2, comma 2 is going to become 5, comma 2. It should be right here. This graph is kind of small. 5, comma 2. And then 5, comma 3 should become 8, comma 3. So that's a shift right 3. Notice that we didn't do anything to the outside of your function, right? So the only thing that should change is going to be your inputs. Inputs is another word for x values. So only your x values should change in this case. So if you have something on the inside, it's going to be a horizontal shift. So then our next graph, what we want to look at is let's take 3 times f of x. So let's look at this again. Are we changing? Here's your inputs. Does anything change to your x values? Are we doing anything to them? Yes or no? Do we add or subtract or multiply anything on the inside?
No.
No. So your inputs shouldn't change. But what's going to change? You're going to take your output. This is your output. And once you get your output, what are you going to do? You're going to multiply by 3. So that means this is going to be a vertical stretch. Our graph should be higher than it was. And this might go off your graphs a little bit. But we had the point 1, negative 1. If we're multiplying all of our outputs, all of our y values by 3, 1, negative 1 becomes 1, negative 3. Because you multiply all your y values by 3. So this is a vertical stretch. Really what we did was we multiplied the y values times by 3. Over here we did x values plus 3. Right? So times. Alright, so then 2 comma 2 should become 2 comma 6. So that's going to be here 2, 6. Because we're multiplying the y values by 3. And 5 comma 3 should become 5, 9. Right there. All we did was we plugged in our same inputs, meaning the x value didn't change. And what we got out, we multiplied the outputs, the y values by 3. So this becomes a vertical stretch. With absolute values, we said it was a vertical stretch, but what we said was we changed the right side slope, right? And so when the numbers got large, what happened to your graph? As the a value got bigger and bigger, what happened to your absolute value graph? You guys had a graph view of these. Spencer? Oh, I think it's nice.
No.
When your a value gets larger in front of the absolute value, what happened to your v-shaped graph?
It got like skinnier.
Skinnier, right? Got closer together, it got narrow. That's really what's happened, the same thing that's happening here, because the values are stretching, right? They're going farther up. So you go right one, and then you're going up a lot higher with your absolute value graph. In this case, they're just being stretched. All right, so now we've talked about vertical shifts, horizontal shifts, vertical stretches and shrinks. So the next thing we're going to want to look at then is if our a value is negative. So let's take negative of x. It'll come back. Oh, come on. It does this sometimes. It doesn't like me. It's going to come back. Have faith. All right. So, negative absolute or negative f of x. What did negative do to the absolute value? Here's from all the same people. What did just the negative? What did that do back to your absolute value?
Make it smaller.
It did not make it smaller.
It made it become a negative graph, negative slope.
Okay, negative slope, and so visually, what did that do?
It flipped it
It
upside down.
flipped it upside down, right? And that's exactly what's going to happen here. So once again, your inputs don't change. Inputs are the same. You take your outputs, right? Here's your outputs. And all you're going to do is you're going to make your outputs the opposite sign. So what that does is this is a reflection. So we have the point 1, negative 1. If we're reflecting this, the x values don't change, right? They stay at x. The outputs are what's changed. So 1, negative 1 becomes 1, positive 1. Two comma 2, the outputs flip signs, right? They're going to switch values. So 2 comma 2 becomes 2 comma negative 2. And 5 comma 3, our outputs are going to switch. So it's going to become 5, negative 3. And this should, if you look at your first graph to this graph, this should be an exact reflection, a mirror image across that x-axis. So what we want to finish with is, what if we change the sign of our inputs? So we don't change our outputs. What if we changed the sign of our inputs? So we multiply the inside by a negative 1. So now we're going to change the inputs, which is another word for x values, meaning your output doesn't change, right? We didn't do anything to the outside of the function. So your outputs stay the same. Your inputs are going to be what flip signs. So we had the point 1, negative 1. If the inputs are flipping signs, it should become negative 1, negative 1. The x values are going to change, the y values will stay the same. 2 comma 2 should become negative 2, 2. And 5, 3 should become negative 5, 3. So if you compare your first graph now to your last graph, it should be a complete reflection across the y-axis. All right, let's go over these. So I've got them broken up here on the board. I'm going to call on you guys, but all I want you guys to say is what does each of these things mean? So like that negative 2. Let's see, Emma, what does that negative 2 mean for us?
That you minus, you minus 2 from the y.
There you go, right? That's all it is. You just minus 2 from the y's. So we're going to take our graph, and all of our y values are going to go down down 2. So negative 2, 3 should become negative 2, 1. Let's see, 0, 2 should become 0, 0. And 2, negative 2 should become 2, negative 4. Y values went down 2, right? All right, so now this would be down 2. This plus 2. Zach, what does that plus 2 tell us? Left 2. Right, opposite what we think it should be. So the point negative 2, 3, which was here, is going to go left 2. So negative 4, 3. 0, 2 is going to become negative 2, 2. And 2, negative 2 is going to become 0, negative 2. There we are. So it's just shift left 2. All right, moving on to this next one, that -3 on the inside. Tell me, what does that -3 on the inside tell us?
It says that that's what the X value is gonna change by. It's gonna go right 3.
There we go, this one's gonna go right 3, because the X values change. The input's what's changing, so now we have -2, 3 is gonna go right 3, so now it's here at 1, 3. 0, 2 should become 3, 2. And then -2 should become 5, -2. So notice that all three of these graphs, they look the same, right? All they are just shifts of each other. It's just that exact same graph, you're picking it up and moving it around. It's once we add something on the outside like this is when it changes. So then this 2 on the outside, Eileen, what does that do to the graph?
It stretches or shrinks it.
Alright, it stretches or shrinks it. In this case, it's bigger than 1, so it's going to stretch it. So that means that -2, 3 is going to go off my graph, right? Because -2, 3 should go to -2, 6. That's going to be right here. 0, 2 should go to 0, 4. And 2, -2, multiplying all the y values by 2, should be at 2, -4. This is multiply y by 2. So there's your graph. It's a stretch, right? Your original graph got stretched out. Alright, we still got 4 graphs to go over though. So now we have -g of x. So Carter, that negative on the outside, what does that do to our graph?
It switches the y values.
Alright,
Opposite.
switch y values. What's another way to say that exact same thing? Anybody?
Reflected of the x.
Yeah, this is going to be reflect over the x-axis. Alright, so let's go -2, 3, -2, 3, which was here, now becomes -2, -3. 0, 2 becomes 0, -2. And 2, -2, which is here, becomes 2, +2. There's our graph. Reflection across the x-axis. Shiloh, if we put that negative on the inside, what does that do to our graph then?
It would make the x negative.
It makes all the x's negative, right? There we go. So we're going to say x negative. And what's another way to say that as well? Anton?
Reflection on the y-axis.
There you go. Same thing. Doesn't matter how you think about it. So then our -2, 3 becomes a +2, 3. Our 0, 2 becomes 0, 2, right? It doesn't change. And 2, -2 becomes -2, -2. There we go. Getting somewhere now. Wait for it. Lexi, what does that -3 do to this graph?
It's a reflection and a stretch.
All right. Maybe. Okay. Reflection and a stretch. So take our -2, 3. We're going to flip it and make it -2, -9. That's all the way down here. I know this is a pretty small graph. 0, 2 becomes 0, -6. And 2, -2 becomes 2, +6. We almost made it all, class. You might not get to draw the graph for the next one on me. Alright, last one before this just completely breaks down on me. Somebody raise their hand. What does the both ones tell us to do? Have we go?
Up 1 and left 1.
Up 1, left 1. Take your original graph, go up 1, left 1. So -2, 3, up 1, left 1 is now here. 0, 2 goes up 1, left 1 is now here. And 2, -2, up 1, left 1 is there. Let's see if I can get it back on the board.